We're here at 369 Warren Street, our new 475 office and warehouse. When we first discovered this building, 5 cars parked here in a very danky old garage with flickering fluorescent lights, a regular 2-bedroom apartment on top. It was really hard to imagine what we could make in this space that would fit our mission and our company as a low carbon efficient project. We'll introduce you today how we achieved this. So let's go have a look inside. To stay true to our name, this building of course had to be a passive house. That meant that it needed to use less than 4.75 kilobtu per square foot per year. Actually, with a great preliminary lower door test of 0.3 air changes per hour, we're getting that number down 20% more efficient, below 4, which is great. To do a certified passive house, we needed to implement the 5 core principles of passive house. Highly insulated envelope, an airtight envelope, thermal bridge free, high performance windows and doors, and Skylight, and as well high performance heat recovery ventilation. So it will show you all those aspects and materials that we supply to North America for this purpose.
We have sort of an ideal condition here for an interior insulated masonry building. Behind the finish, we have a continuous layer of mineral wool insulation, then an air barrier layer, and then a framed cavity also with insulation. So about 7 inches of insulation on the interior side of this wall. Because we have that continuous insulation layer that comes pretty much right in line with our wood framed window, we have a really good SI install value, so we're getting the full benefit of the performance of this window in this wall system. Similarly, at the roof, we have continuous mineral wool insulation above the roof deck that ties into the Lamelux skylights, and then we're insulating up the curb, really reducing the thermal bridging of those details as well. So all in all, great details in this project.
In addition to having insulation on all 6 sides of this project, it's really important to have continuous air barriers on all 6 sides as well. At the walls, we achieved this by applying Viscon to the structural masonry. That Viscon is continuous from floor to ceiling and acts as both an air barrier and a capillary break. That layer is continuous around the glulam beams above with Viscon fiber making that connection. And then inside of our Viscon layer, we have a continuous layer of mineral wool insulation. That insulation is protected by Intello Plus, which is both an air barrier and a humidity-dependent vapor control layer. That layer is continuously airtight by having its seams sealed with Tesconvana airtight tape. At the roof, that Intello Plus layer meets the Adhero Visto above the NLT. That Adhero Visto is both temporary weather protection for the NLT during construction and a continuous air barrier that connects to the Intello Plus to ensure a continuity of the air barrier all the way around the project. To ensure the air barriers are continuous, it's really important to make sure that our connections to things like window and door openings are smooth and continuous. So the Intello Plus on these walls wraps into these rough openings and is connected to the high performance window frames with Contiga Solido IQ tape. The advantage of Contiga Solido IQ is that it has a stronger adhesive, so it can bond to masonry without a primer, and it's also humidity dependent, so it works well with the Intello Plus and can be used on both the interior and exterior. The existing slab on grade below these floors was preserved, so we had to insulate and air seal above that. To do that, we used Stego Home Wrap directly on top of that slab on grade to be an air barrier and a vapor retarder. To make sure it was continuously airtight, we sealed the seams with Compigo tape, and then we wrapped that air barrier up onto the walls to connect to the Viscon, and we connected that with Contiga Solido IQ tape. Above the insulation, we have plywood subflooring, and the seams of that are taped with Tesconvana to make that a continuous air barrier as well, and that layer connects to the Intello Plus on the walls. We want to extend our gratitude to Rockwool for their support on this project, supplying mineral wool insulation for all 6 sides. That mineral wool really allowed us to achieve a low embodied carbon and a 99% foam-free enclosure.
As a historic masonry wall, it was really challenging to get our continuous insulation on the outside of the wall. So instead, we put it on the inside. And so here we have a new product called Smart Rock, which is a semi-rigid stone wool insulation with an integral smart vapor control layer. In this case, it's the Intello membrane. And so the beauty of this is we can pin this to the masonry wall, so you can use different types of thermally broken anchors. And then you have an integral air barrier to the inside, which you tape the seams and you get your air tightness. You also get your vapor control, which is really important for these masonry walls to be able to dry to the inside, but prevent the outward vapor flow during the heating degree months. The only thermal bridging you really have to worry about might be the joists or the floor slabs and trying to work through some of those details. But this is a great way in the field of the wall to get continuous insulation. You can see here there's also wood studs that are inboard. This will help serve as your service cavity, so you can get your electrical conduit, your plumbing conduit. And then you could also throw some lower density stone wool insulation into those stud cavities as well to get you additional thermal value in the assembly.
In this project, they wanted to achieve continuous insulation on the existing concrete floor. So they integrated some of our high density comfort board 110, 2.5 inches of that. And then they placed the 2 layers of the plywood boards down and then the finished floor, which really provided great continuous insulation and ample compressive strength to kind of hold things together. So it's a good fit for rock wool.
So we're up on the roof now. On this building, they went with a foam-free stone wool insulation roof. Rockwool makes a series of products called Top Rock, which is roughly R3.8 per inch. They used 8 inches of it. And then for the taper, they added an additional 1 to 5 inches to get the proper slope for drainage. Really good, obviously, for fire resistance. It's non-combustible and really great for acoustics. Only challenges here really are the skylights, where they really needed to have an opportunity to cut material. And so stone wool is a great option for that because you can cut it easily with a serrated knife to achieve the continuous insulation that you need to meet the Passive House requirements and get the certification on this project.
It was an easy decision to use the Brink Flare units for ventilation here at our new headquarters. We've already worked to lower the VOCs by carefully selecting the building materials. However, we still must eliminate produced contaminants and bring in fresh, oxygenated, and comfortable air to the workplace. The Brink Flare units have the highest efficiencies and are the most compact in North America for their class. The units are robust, reliable, easy to maintain, and they include the latest technologies, which includes a automatic bypass, a built-in preheater, as well as vane anemometers, which carefully balance the incoming and outgoing air no matter the density. Insulated ducts should always be used for the intake as well as the exhaust of the Brink system, because if we're thinking winter, that's going to be very cold air coming in through those ducts. It's important to keep those runs very short, as you want to minimize the amount of heat loss. And the longer they are, the more surface area you have to lose heat from your home to those ducts. So we kept those short by bringing the duct straight up through the roof here. The roof was the easiest option for us because of our tight site constrictions. So we used a roof terminal with our flat roof flashing kit to bring in fresh air to our office here. From there, then we are going to go through the core of the unit. We have an intelligent preheater that only turns on when needed. Then we have our MERV 13 filter. It's going to filter that fresh air and bring that fresh air into where it's needed. We have an optional pure induct, which is a post filter system. It's an ionization filter system that charges the particles and results in above HEPA level filtration. For the supply side, we just used one duct and dumped the air into our open office, as it's an open floor plan. And we also used a CO2 sensor in the main office space. That way we can have demand control ventilation due to our variable occupancy. The system will automatically ramp up based on how many occupants are there, keeping our CO2 levels within healthy ranges. For the exhaust system, we did use our home run system. The home run system includes a manifold and 3-inch ducts that distribute air throughout the space, or in this case, pull air from various spaces, including bathrooms, our kitchenette, and our mechanical room downstairs. So for that, we use 3-inch ducting, which fits in a nice 2x4 wall. Some spaces require 1, 2, or 3 ducts pulling air from those. We used a combination of both semi-rigid 3-inch ducting as well as 3-inch flex ducting, as some of the ducting needed to go through our fire-rated floor. These ducts then connect to a 2 or 3 port diffuser box, and you get more air pulled from each space. I'm proud to be working for a company that values its employees' health and provides excellent indoor air quality so we can flourish.
When you first walk into our new office, you're greeted by natural light flooding the first floor space thanks to the Lemlux FE circular skylight installed 2 stories above. This epicircular skylight is prefabricated on a 20-inch insulated curb for a roof opening with a diameter of approximately 71 inches. This insulated curb is a perfect fit for our passive house retrofit, as it allows us to maintain thermal continuity with the surrounding roof structure while also achieving our minimum 6 inches of clearance over the finished roof. With triple layer insulated glazing and a thermally broken aluminum profile, the skylight was also able to easily achieve the passive house requirements that we needed for our certification. As you make your way up the stairs to the second story of our new office, more light pours in from above via the Lamlux comfort swing. This roof access skylight is ideally suited for access over a staircase thanks to its span of about 3 foot 3 inches by 11 foot 6 inches. The Lamlux comfort swing is operated along a hinged edge via pneumatic pistons concealed on the short sides of the skylight. With triple layer insulated glazing, a thermally broken aluminum profile, and a prefabricated insulated curb, this skylight was ideally suited for our passive house retrofit while also allowing for access to our beautiful new roof deck. We even chose 475's signature blue for the profile to add a splash of color to the space. Above our main office space is the crown jewel of our new office, the Lamlux PR60. The Lamlux PR60 is a high-performance knockdown system, meaning it is delivered to the job site as a custom kit of parts, including triple-layer insulated glazing units, thermally broken aluminum profiles, and insulated flashing connections to the existing structure. According to Nikola Tesla, the number 369, our new office address, has special significance in the inner workings of the universe. We look to implement these numbers wherever possible in the fabric of our new building, including with the skylight, which features 3 glass fields with lengths corresponding to the ratio between the numbers 3, 6, and 9. The smallest glass field is a motor-operated ventilator flap, which opens to allow fresh air to ventilate into the office space below.
We're excited for this next chapter in our company. Enjoy showing you around our headquarters in this video. Of course, you're always welcome to come check it out in person.